Does your codebase look something like this? One giant components folder where everything gets dumped into. Data fetching shoved straight into server components because, well, why not? And one massive actions file packed with all of your server actions. Sounds familiar? Yeah, I've been there. And trust me, these are huge mistakes that make your codebase impossible to scale. But here's the good news. In this video, I will show you exactly how I fixed those mistakes by moving to a feature-based architecture and how you can do the same. So without any further ado, let's go! Alright, so before we now look at how you should structure your project the right way, let's first of all look at how you should not do it. So this is an example project that I created a few years ago, and to be honest with you, I'm not proud of it, but hey, it's a learning experience, so who cares? So let's first of all look at the folder/route structure in general. So this is a Next.js application, and looking at it, it looks fine. And that's because this is the default setup. You can't really do anything wrong right here. So let's look at the app folder. And this is already a bit more interesting because inside of here, I define my routes, but also my business logic. So in the app folder, I have a dashboard folder. In the dashboard folder, I have a layout file, a page.tsx, nothing groundbreaking. This is standard Next.js. This is how Next.js works. You create a folder with a page.tsx and then this becomes a route. So I would say the route structure is fine. It's not bad, it's not great, it's fine enough, to be quite honest with you. But let's look at something more interesting, and that's how I actually defined my components. Because if you have good eyes, then you will see that I have two component folders. Huh? What do I mean by that? So first of all, right here, I have a components folder with a child UI folder, and then I have a lot of files. These are like shared C and UI components, which are defined or created when you use shared C and UI. So this is fine, right? But in the app folder, I have another components folder. Okay, this is already quite a bad, you could say, architecture. You want to have one components folder. You don't need two folders. Nevertheless, let's look at this components folder because this actually are custom components which I created. And here you should already see the first bad thing. There's no structure. What do I mean by that? Literally, all of these components, all of these files are just thrown into this components folder. I mean, let's look at it like this. If I go into my dashboard, I have this products folder. Inside of here, I have the ID folder with my page.tsx. Do I use a component inside of here? Yes, the edit form component. So if I'm new to the project, I would say, hey, the edit form component, this probably lives somewhere right here. But no, it lives in the main components folder with no real structure. I don't have a child form component or anything like that. It's somewhere right here. So imagine that I would have 10,000 components. Imagine the time I would spend just to find this component. So in this case, I can say edit form. It's right here. So as you see, this is not scalable at all. This is a huge mistake. Now let's look at my mutations layer. So how do I mutate data? Well, in my app folder, I have an actions file. This actions file creates, or I guess defines, a lot of server actions. Create product, then edit product, what else? Delete product, create banner, delete banner, add item. So this code itself is fine. The server action code is fine. But again, there's no separation of concerns. This is code directly related to products. But then I have CRUD operations related to the banner, then to the item. Again, this does not make any sense. You want to have separation. So instead of having this one actions file, I should rather have an actions folder, for example, with multiple subfolders. A subfolder for my item, one for my product, one for my banner, and then inside of these subfolders, I could define all of these server actions. So again, this is a huge mistake and this is not scalable. And then there's one more thing I want to look at, and that's data fetching in general. Let's again go into the products route, so into this page.tsx. And how do I fetch data inside of here? Well, I have two functions. First of all, my export default function, that's fine, you need it, right? But then I have this async function getData. This means I create my query logic in the page itself. Now this at first does not seem like a mistake, and it also works, and you want to fetch data in a server component. This is fine, but you don't want to create your or store your query logic in the page.tsx itself. And I did it with literally every page. So let's go into the general page.tsx for the products. And again, I create my query logic inside of here, and then I call it in the async function or in the export default function. So this works, but you don't want to do that. You want to actually use a data access layer. And I will come to the data access layer a bit later on. This is a big mistake because this creates a lot of authorization bugs, and also this is not very scalable because you now mix your UI layer with your data layer, your business logic with your UI layer. You shouldn't do something like this. And now we talked a bit about the code itself. Let's maybe look at a diagram that explains this code base, the structure, even better. So this is Eraser, and inside of here I created a beautiful diagram as always, and as you see, not good. So this is our project, Next.js project, and I have a lot of features. So let's again go back. This is an e-commerce application, so that's why I have an orders route, a products route, the ID route of the product, so the individual product and stuff like that. And I call these routes features. So in general, for example, this product route, this is kinda a feature. The deletion of the product is kinda a feature. The banner is a feature. So in general, I have a lot of features. Feature 1, 2, 3, 4, 5, 6, 7, whatever. And all of these features are directly linked to one data, components, utils, and routes layer. What do I mean by that again? Well, for example, here I have a back folder with a page.tsx. Again, I fetch data inside of here. This is a server component. This is fine enough. And then if I scroll a bit to the bottom, I use a component, the shopping bag component. Where is this component defined? Well, again, it's defined in the general components folder. Then, for example, let's imagine I would use utils. Where do I store all of my utils? Well, in this one file, utils. Here I only have one util, but I think you can imagine what I mean. The core problem is that I literally store everything in one layer. So I don't have many layers, I have one layer, and then I pretty much connect everything to this one layer. This is kinda stupid and not scalable, because again, if I have 10,000 components and they all live in one components folder, good luck finding everything. If I have 10,000 utils, one util to do this and then that and then to generate an image, well then again, good luck finding everything and good luck working on everything. So as you see, this is kinda a mistake. You don't want to have one layer of data, components, utils, and routes. Instead, you want to have multiple layers which are then directly linked to the feature. What do I mean by that, and how does this look like? Good question. Let me show it to you. So this is how a good project structure should look like. Again, we have the Next.js project and we have our features. Now again, what is a feature? A feature could literally be anything. This could be your about route, but this could also be your bag. So for example, a shopping bag, and then you can add items to a shopping bag. This is a feature. And now instead of actually storing all of your data, components, utils, and routes in one layer, you actually create this group for each feature. So each feature now has its own layer for data, components, utils, and routes, which makes it very easy for co-location. So for example, if a new employee comes to your team, he will instantly know what code is related to what feature, if this makes sense. So for example, I have feature A, B, C, and all of these features have their own layer. And then for example, feature A has a child feature B. So let's imagine we have a shopping bag, and the shopping bag has a sub feature, which is to add an item to the shopping bag. This is a sub feature. And this sub feature again has its own layer of data, components, utils, and routes. And how does this look in effect? Or maybe before we look at it in effect, let me maybe explain the term feature-based architecture. So a lot of people also call it vertical slice architecture. I'm not sure if I would agree on it, but if you want to call it vertical slice slice architecture, then be my guest. I honestly don't care. But how does it work exactly? Well, you organize code by features. Example, payments, users, orders, stuff like that. Each feature typically contains all layers it needs. This means the UI, domain, data, utils, components, stuff like that. And the main goal is high cohesion within a feature and low coupling between features. So that's the main goal of feature-based architecture. But how does it look in a real code base? Because this is only a diagram. Good question. Let me show it to you. Now, looking again at the route structure in general, you will see it looks very similar to the previous example, to the other bad code base. And that's because, again, you can't really do anything wrong with your folder with your route structure. The route structure always works the same in Next.js. You have a folder with a page.tsx. So this is fine enough. But here's the thing. You will see something interesting. I have these parentheses marketing, and then I have this org. So these are two routes actually. The org folder, this is a route, and then this parentheses marketing folder, this is also a route. What are these parentheses? Well, that's what you call a route group. What even is a route group? Good question. So route groups are a folder convention that let you organize routes by category or theme. So a route group can be created by wrapping a folder's name in parentheses, and that's what I did. Parentheses marketing. And now here's the interesting thing. This convention indicates the folder is for organizational purposes and should not be included in the route URL path. So here's the thing. This org folder, this will be appended to the URL /org. But this marketing folder, this route group, won't be included in the URL. And this is because I use it just for organizational purposes. Inside of here, I store my marketing pages. I can also show it to you. So this is the actual project. And as you see in the URL, this isn't a /marketing route. No, this is the index page. So even though I have a folder right here, it's actually not included in the URL. And also, if you wonder what project this even is, well, this is the project for my next long form video, so stay tuned, it's very cool. Then let's look at components. So again, if we look at the diagram, you will see that each feature has its own components. What do I mean by that? Does this mean that I have one components folder with multiple subfolders? Or do I literally go into the route and create a components folder in there? Well, let me again show it to you. So this is my marketing route group, and inside of here I have an underscore components folder, and inside of here I store components directly linked to this feature, to the marketing side. I have a hero section. This is literally what you see here. So let me show it to you. This is the hero section, and then I also have a navbar, and the navbar is this top navbar. Who would have thought? Groundbreaking. All of this code, or these two components, are defined inside of here because they are only used in this section. If the hero section would be reused in multiple places, in the dashboard, in the marketing page, then I wouldn't define it inside of here. Instead, then I would use a global components folder. Because here's the thing, if I open my folder structure, I have a global components folder. So outside of the app folder, I have a components folder. And in this components folder, I store all components that are reused in multiple places. So for example, I have an UI folder with all of the shared C and UI components. I reuse them in multiple places. I have a rich text editor folder. Inside of here, I store all of my rich text editor related code, and I used or reused this editor in multiple places. And that's why it's defined in the main components folder and not in the app folder in a specific feature. And now you might also ask me, hey Jan, why do you use this underscore components convention? Why isn't this just a general components folder? Good question. If we go to the Next.js documentation, then you will find this section here, private folders. Private folders can be created by prefixing a folder with an underscore folder name. This indicates the folder is a private implementation detail and should not be considered by the routing system, thereby opting the folder and all of its subfolders out of routing. You don't even have to use the underscore because Next.js is quite smart. It knows that, hey, this isn't a route because there's no page.tsx defined here, so you don't need to use the underscore convention. I just use it because it was created in the pages router. I used the pages router and that's why I use the underscore here, but you don't have to use it. Let's now also look at data fetching, because data fetching is also a very core part of your folder structure. So first of all, here I have my org folder, and in the org folder I have a layout file. In this layout file I fetch data. So looking at the file, you'll see this is a server component first of all, and then in the server component I use TanStack query or React query for all of the OGs. I just prefetch my data on the server side and then I pretty much pass it to my client component. This is not very important. The important thing is I fetch data on the server side. That's the exact same thing as I did in the previous example in the bad code base. The only difference is I don't define an async function inside of here, or in other words, I don't define the query logic in this file. Instead, I have a separate location. So for this code base, I use ORPC. This means in my folder structure, I have a router, and in the router I first of all have the index file. This index file defines all of the functions, or you could say routes. And for example, I have this organization file, and inside of here I define all of my routes. The get routes, so list organizations, then for example create organizations, this is a mutation, but in general my query logic lives in a separate file. It's not defined in the actual page where I fetch my data. And now you might ask me, hey Jan, why is it a good idea to store all of your data, you could say query logic, in a separate file? Why should I not just define everything in the page.tsx? I mean, at the end of the day, I use it inside of here, so it would make sense to just create an async function inside of here. Sure, again, it works, but the Next.js team does not even recommend doing that. They want you to store all of your query logic in a separate file as I did, or in a separate location. So for new projects, we recommend creating a dedicated data access layer. This is an internal library that controls how and when data is fetched and what gets passed to your render context. A data access layer should only run on the server side, perform authorization checks, and return safe, minimal data transfer objects. And this approach, this means the data access layer centralizes all data access logic, making it easier to enforce consistent data access and reduce the risks of authorization bugs. So let me show it to you again. Let's look at this file or this function, list organizations. So again, I use ORPC. What even is ORPC? Well, ORPC makes it easy to create type-safe APIs. It's like TRPC, it's an alternative. I like it a bit more, but this is not really important. The important thing is that my query logic is in a separate file. And here I also have authorization logic, because as you see, this is equal to auth with org. Auth with org is actually a middleware. So here I have a middleware's folder, and then I have an auth file. Inside of here, I make sure that the user is authorized. If the user does not have a valid session, I throw an error. If we have a user, well, then great, then everything works. And as you see again, this is equal to this middleware. This means before my handler runs with all of my query logic, I first of all make sure that the user is authenticated. And once I know that the user is authenticated, my handler will run, which means I will fetch my organizations. For example, I can also show you an example where I don't use ORPC. So this is the code base for my website, Marshall Code. Here I have a data folder. This data folder has multiple subfolders: admin, payment, tutorial, user. And for example, in the tutorial folder, I have a file, get free tutorials. Inside of here, I use import server only. I make sure that this function can only be called from the server side. I then have my query logic, and that's it. I return my data, and then I call this function in my server component. For example, here I have another function, get settings user data. And here I call a require user function, and this require user function makes sure that the user is authenticated. So in my new project, I use ORPC. Here I just use standard TypeScript code, so it does not really make a difference. The only important thing is that you store all of this query logic in a separate file, and that you make sure that you authorize the query logic. You want to make sure that the user has a valid session and maybe the correct permissions and stuff like that. And I have also a separate video on the data access layer. I will link it on the top right or left corner. Check it out. It's very, very important for you to use the data access layer. And then let's maybe also look at my mutations layer. So again, I use ORPC for my whole data layer, both for data fetching and mutations. So in this organization file, for example, I first of all have the list organizations function. This is where I fetch my data. And then I also have this function, create organization, and this is my mutation layer. So as you see here in this project, I don't use server actions, but if we go back to my Marshall codebase, then you will see that I use server actions inside of here. So for example, in the settings folder, I have an actions file, and this actions file only stores server actions that are directly linked to the settings. In this case, update settings user data. I make sure that the user is authenticated, that the user has a valid user session, and then I create my mutation. So this uses the feature-based architecture. Action files are defined directly in the feature that they are mutating, if this makes sense. So I don't have one actions file. Instead, every actions file is defined in the actual feature that it's mutating. And I often also see people asking themselves, hey, when should I break specific code from a file into a separate component? And here's the thing, there's no one size fits all answer. It's honestly personal choice. I personally break code into separate components once the file becomes too big to manage. So this is, for example, my channel ID page. And you know what? Just to understand everything a bit better, let me show you the UI. So this is a Slack-like application. I have this organization sidebar, my channel sidebar, then the main content. I can write a message here, and then I will see it inside of here. This is all cool. This is all great. And then this layout or this page pretty much structures everything. I have a channel header, a message list component, a message input form, and then this thread sidebar. So here I broke everything into separate components because it's easier to manage. I don't reuse this channel header. I only use it inside of here, but writing the code in this page.tsx would just be annoying to manage. But now I have a separate component just for the channel header, and I can always reference it. So in my opinion, there are two reasons to break code into a separate component, and that's A, the file is too big to manage, or B, you want to reuse it in multiple places. So for example, I have my components or my general components folder, and this rich text editor is reused in multiple places. So it makes sense to create a separate component and then reuse it, and not to just define it in the page.tsx. And yes, everyone, that's already it. This is how you structure your project like a senior engineer. Okay, I'm joking, because here's the thing. There is no right way to structure a project. There are certain architectures that are better for certain use cases. This is what I use. This is what I recommend. Nevertheless, if you think that you have a better architecture that you use privately or at work, please let me know. I'm always open to learn better things, to be honest with you. So if you have a better architecture, let me know in the comments, hit the like button, and now enjoy your day, and I hope I can see you in the next one. So bye bye.